We are live in both YouTube, sir.
Okay. So there is one Gauri Nanda. Who is she?
Good morning, sir.
Yeah, good morning. You are from NPTEL office.
No, sir. I'm a student of ISA Tirupati.
I said, okay. You have any questions?
No, sir. I've been watching your lectures.
Okay. So you want to listen the convocation?
Yes, sir.
Okay, okay. So those who joined can ask the question. Anyone is Siddharth. So you want to answer your questions which is listed?
Hello.
Siddharth.
Yes, sir. I'll put it in the chat box, sir.
Yeah. So no, already I got the Excel actually. So your first question was on what is the scope for seismic slope stability analysis? What research can be done in this area? See, the landslide is one of the big disaster due to the earthquake. So particularly people living in the hilly regions, this landslide create a lot of damages and the consequences, so economic as well as the life losses. Okay, so as per research concern, so most of the landslide so works with the slope stability method, which they assume that some kind of the horizontal coefficient of the earthquake taken into account, and then they do the research. Or they also do the time history analysis, which is a 2D based one. But as per my experience in the engineering seismology, so the landslide basically is the function of the slope of the ground, and then what are the vegetation and how the soil property varies spatially. So which somebody was measure accurately and then model that. So basically one can predict the static as well as the seismic instability time. So which can minimize to prevent the damage or collapse, or somebody can improve also, even they improve that even for the given seismic condition. So what are the improvement, how it will be stable and all. So there are foreign countries where they do 24/7 continuous monitoring. So that even the small displacement taking place in the slope due to the rain or due to the any activity, so they immediately kind of evacuate the people on downstream side and try to do that, which is they integrate with some of the instrumentation plus a GIS platform and live monitoring kind of things. So such kind of like the analysis, monitoring, and then the characterizing. So these are all some of the research one can take up and then do contribute in that area. So, but in India, most of the people does the slope stability with like assumed perfect slope, not the real slope, which is what you see in this one. So that is why even many times if you see most of the road where they constructed, particularly North India, during rain or other time, it get failed because the slopes are not properly analyzed. So before doing any construction or cutting up the section, they have to check upstream slope stability. Even that fails, the road should not cut, or road should not affect it, which is very common scenario in the North India. So the accurate way of doing such work, representative way of measuring the properties, modeling, and improving that will minimize such kind of hazard. There is a big scope in this area. So second is that why body wave magnitude, surface wave magnitude get constant after reaching certain magnitude, which is also asked by the one of the student, I think. So Arpan Maiti, I think he is also asked, I know he is present or not. So both of them I will be answering that. So this magnitude, except the moment magnitude, most of the magnitude is the function of your recorded acceleration time is the amplitude. Okay, like the S wave, P wave, or the surface wave amplitude they use in the log scale to get a magnitude values. So this amplitude also affected by the where the wave passes through, how many different medium it passes through and all. So in the same distance, the rock and the soil will have different amplitude. So because of that, the empirical correlations or model what they use to estimate magnitude, after some time, you get a same magnitude irrespective of the amplitude, because the amplitude does not contribute. So which is called that a magnitude saturation. Okay, so that is why the body wave magnitude, surface wave magnitude, which is affected by the medium where it travels, and it is purely accounted the amplitude, because the earthquake strength is considered as a amplitude of the wave, which is the function of your subsurface material which passes through from the source to the recording station. So because of that, this magnitude get constant value after reaching some level, which is called as a magnitude saturation. So what is the difference between the liquefaction and piping? So the liquefaction is actually the loss of shear strength due to the dynamic loading, such as a pile driving, earthquake. So such kind of phenomena is called liquefaction. The piping is actually the loss of shear strength, where the soil flow in the water or erode along with the water, but it is due to the water seepage or the water pressure. So generally in the tap, the water tap or water pipeline below the mud without bitumen, if you see, so this mud actually what happened. So when pipe leaks, so due to the pressure, the sandy soil try to, like the sand particle try to come out along with the water and flow. So such kind of scenario is piping, or in the lateritic soil and other some of the soils. So the water pressure will separate your particles. So and then try to move the water will try to move along with the soil particle will move along with the water. Such a scenario create a holes, and that kind of scenario also called as a piping. So among the S, P and surface wave, which one is more severe? So when you look at a particle movement actually, so when the wave passes, the particle should vibrate so differently for different type of wave. For example, the P wave, the particle moves back and forth. The S wave, it moves perpendicular to the wave motion. And then the surface wave, it moves perpendicular, but it is rotating, and the amplitudes are high at surface. When depth goes, it is low. So when the particles are moving perpendicular or rotates along the wave direction, those waves can cause more displacement in the soil. Okay, so that is why the S and surface waves are more severe than the P wave. So effect on this one. Okay. So not related to course, so kappa factor, how estimate any numerical available on this. Now the kappa factor generally used as a factor which is represent the damping or the attenuation of this one. So these factors should be derived based on the recorded data. Okay, so there are some empirical equations people are derived based on the recorded data, but it is always better to use P and S wave recorded from the particular location, and then you estimate a kappa factor. There is a standard method for that to estimate. How can the seismology help to explore moon or any other planet, say Saturn, Mars? See, actually the seismic wave is the one of the potential wave to which differentiate a stiffness and a density. Okay, so all the mining materials, whatever they find out, no. So the mine materials like iron ore is having the completely different density and stiffness when compared to nearby soil. Similarly, the gold. So then similar to the this one, diamond. So all this mineral exploration is possible because of the seismic survey. Even you may be knowing that seismic refraction survey is widely used for the oil exploration. So by considering that, so the seismology is used to measure so how the kind of the density and the stiffness varies in the particular planet. That is the one thing. Second, the seismology also help to understand the layering of the earth through its measurement. Okay, so like we say earthquake, no, it's the quake happens in the earth, it is called as earthquake. The same quake happens in the moon quake, so Mars quake. There are recorded. The people put seismometer in the moon as well as in the Mars. So where they see the record of vibration, which is happening due to the some impact in the moon or Mars, or due to the some tectonic or kind of, it is not proved that they are the plates and all, but still there is some kind of vibration taking place, which is recorded in the seismometer, which they also call it as a moon quake and Mars quake. So the seismology can be used to understand the tectonic settings of any planet, and also to explore the interior of the planet, like it is a liquid or gas or the solid. If the solid, what type of material it present. Okay, so it's a kind of the high density material, low density material. So that way the seismology is used. So when so the body wave propagates in all direction. So from the source that does not surface, the wave propagation starts. What is that? When the body wave propagates in all directions from the source. So I'm not very sure what was the question actually. Can you elaborate this question, Siddharth?
Like I meant, so like we see that body wave propagates in all the directions. I just wanted to know, like, when the surface wave like propagation starts. I meant that.
No, all the wave propagate in all the direction. Okay. So when the waves are generated, all the wave propagate in all the direction. Depends upon the medium where it passes through. Some of the waves are reduced, are reflected and refracted. Some of the waves are enhanced. Okay, so like amplified and attenuated. So depends upon the different medium it presents. Okay, the wave propagation it's taking place. So generally the body wave travels on all the medium. So it travels very fast. So that is why you reach first body waves. So the next is the S wave, like the part of body wave, the P and the S wave. So you say the X wave reaches. The surface wave generally need a distance to generate a surface wave. As the wave travels, the longer distance where the surface will be generated, near to the source, you will not get too much of surface wave. It generated, but not much. So as the distance moves, the waves are getting modified and enhanced in the surface. Do the frequent and heavy rain trigger earthquake? So there is no proof that rain can trigger a earthquake. But however, there is a fault or geologically weak zone, the rain can percolate inside such kind of scenario, and then it weakens the source. Okay, so the long run, that such kind of weakening can cause a earthquake. One. Second, so the heavy rain, basically nowadays everybody has a dam. Okay, so if the dams are filled due to the heavy rain, so as you know that the storing of water, you increase the pressure applied on the plates. So that such kind of enhanced pressure will trigger a earthquake. That is a reservoir induced earthquake. So like mass minus Swaram is the vestal place on earth. What is this? I don't understand. But I never heard earthquake on I hear Richter scale. Can you elaborate this question, Siddharth?
No, sir, like I meant like in Mawson like it rains heavily, like it is the wettest place, but there's no like about earthquake on a very severe Richter scale, like 8.9 or something.
No, generally
it happens on 3.9 or something like that only.
Okay, so no, see the earthquake magnitude is the function of how the place is very close to the plate boundary. Okay, so it's nowhere related to rain and all. But some of the places, like for example, the Antarctica and all, so since it was ice age old, so where the plates are very deep below, so the earthquakes frequencies are very low. That means it happens once in a 5,000, 10,000, 1 lakh years, something like that. Some of the places where the overburden is less than the plate, and then it happens frequently. So, but according to the elastic rebound theory, there is none of the place in the earth free from earthquake. Okay, so that is why the continental drift of ice age movie, if you see, they say that once upon a time all those places were in the same location and together, but due to the earthquake, it was continents was broken and moved, which is basically says that scientists also proved that Antarctica there was a long back earthquake and all those, which is they call it as ice age earthquake. How the seismic station distributed in our country? Any criteria? No, right now we have around 130 to 150 seismic station, which was located based on the IMD importance. It's nothing like they given 500-meter one station or 500-kilometer one station and all. Wherever they possible to like considering the station safety and also the hosting support. So they put a station wherever possible. But the number of station available, I think up to 150 you can take. But that is very less number when compared to the surface area of our country. So there is anyone joined new people? So nobody joined. Okay, I will answer those questions irrespective of they join or not. So there is a what is mean by seismic slope stability, how it is done, what is the pursue research on that, which is already I kind of told, including covering the remote sensing. So why body wave surface getting constant? That is a question also is answered. So in assignment 1, question 7, so in hilly area flood, so fire, switches, landslide can occur. So, but correct answer is fire, landslide only. But the correct answer is fire and landslide. So because the switches you need the water storage. Generally, the hilly area, what happens? You will not have the lake because it is sloped one. So obviously, the switches you can't expect. So flood also because it's slope, even a small water falls, it keep on moving. So flood also not possible. So the fire and landslide due to earthquake is correct answer. So there is any certification to become a seismologist by independent body or agency? There is no such provisions are there because in our country, civil engineers mostly are the geophysicists or seismologists. So everybody does the seismology related research work as well as the publication. So the importance is that how well you are familiar with the subject, how you understand, how do you apply. That is what important rather than certification. Right now, as per my knowledge, there is no certifications are available. He is actually Vivek Kumar Parge. So he is engineer actually. He is taken our course. It's nice to see that some practical people also try to understand it. I think I have answered all the questions. So let me see any other people raise your question. Gauri Nanda, you can ask your doubt, no issue. Gauri?
Yes, sir. Actually, sir, I was traveling, so I thought my net will go. That's why I.
Yeah, you ask whatever net is there, we'll answer. Don't worry.
Sir, it's outside the lectures you have
It
taken.
doesn't
sir.
matter, yeah.
Sir, is there any relation between seismicity of a region and the ground motion prediction equation? How extent it can predict?
No, generally when the more seismicity, more recorded earthquake data will be available. But obviously your ground motion prediction model should be very accurate if they use all the recorded earthquake data properly. But as such, we say that there is no direct relation like that. For example, Himalayan region has a more highly seismic seismicity region, but the number of earthquake data available to the researchers are very limited. So because of that, if you see the GMPs developed for Himalayan region, very few GMPs are kind of robust. Rest of them are kind of useless and not even applicable. Okay, so it all depends upon the how the data recording was done, how the data recording taken into account for the GMP development. Because the GMP development is done on two phases. One is that people use recorded earthquake data and arrive all the source path parameters and then the site parameters and then relate that with the recorded peak ground acceleration. If the recorded data are available in plenty, like magnitude, distance combination, and the site classes, have huge amount of data, then your GMPs will be obviously all right. Sometime what happened, the historic earthquake may be reported, but you may not have the recorded data. But the micro earthquake data can be used and they estimated the source and path parameters. One can generate a simulator. Okay, synthetically the earthquake data for this condition and use them to develop a GMPs, which is kind of ground motion prediction developed using the simulated data. So in India, if we see that recorded data based GMPs are very limited, most of them are simulated based data. Due to lack of recorded data first, second, even the available recorded data is not accessible to researcher. Okay, so many of the data which is digitalized by the IMD and then the Ministry of Earth Science, so which is not openly available to researchers, even though they say that you write a letter, we supply and all, but it is very difficult to get a proper data as per our experience, which we are doing the seismology research since 2004. Okay, so as such, there is no relation, but there should be relation between the seismicity and GMP.
Okay,
India,
sir,
there is no relation, but if you look at the same way with America, so Western America, like the San Francisco and all, they have very good GMP prediction model. Even they have the very closest earthquake time prediction. So, and then they can estimate a spectrum very accurately because there is a plenty of instrumentation is done, understanding is done, study is done, data are available. USGS data you can sit from your desk and download, which makes the direct relation between the GMP and the seismicity. Similarly, the North America, the seismicities are very low. Obviously, the GMPs are predominantly based on the simulated one and data from India or some of the similar intraplate. So the GMPs are kind of limited because of the less seismic activity. It depends upon the region to region. I told both the case, Himalayan region as well as this one is there.
yes, sir. Thank you, sir.
Yeah. So Gauri from ISR, ISR, what this one you are doing? Oh, yeah, ISR, this one. What is that? Gandhinagar.
No, sir. It's in Tirupati, sir.
Why? Okay, this is what is that? Indian Institute. What is that?
Institute of Science, Education and Research, sir.
Ah, okay, okay. So there they also do earthquake related things.
Actually, no, sir. We have just one major related to that, Earth and Climate Sciences.
Okay, okay.
So usually people study solid or geophysics for that and then
Ah.
go for it.
So you are taken engineering seismology this time.
Actually, no, sir. Actually, I did an internship for 2 months for engineering seismology at IIT Madras.
Okay.
My reference for your lecture, sir.
Oh, okay. Who was your this one mentor in IIT Madras?
Professor Doda Gowda, sir.
Oh, okay. He works
Yes,
on hazard analysis.
Yes, sir.
Okay. He is like a kind of this one senior professor in geotech engineering.
Yes, sir. And that's how I got to know about GMP, sir. That's why I asked your
Okay.
Ketan Bajaj equation was there for reference, sir, when I prepared my report.
Yeah. Okay, good.
Yes, sir.
I'm not very sure which part you want, because this entire course involved several parts. For example, simulation of the earthquake, there is a software for that. And then the arriving the P wave, S wave. And then the source parameter, path parameter, there are softwares are available. And then the recorded time velocity data processing, like converting from the acceleration to velocity, velocity to displacement. There is a softwares are available. And converting acceleration to the different spectrum softwares are available. There is plenty of softwares are available. So even the hazard analysis ready-made softwares are available. But anything if you understand and use it, there is no problem. Otherwise, if you don't understand and use, it will end up in wrong result. Because the GMP development is such kind of thing. Because people initially used source parameter, path parameter from the US to simulate ground motion data, but eventually that is not applicable to us. We have to estimate such parameter recorded from our own region. Okay, so something like that. Lakshman, you said there is some guy who is looking for the interaction and all. So did they kind of catch him, or he is online? What is his name?
Sir.
Huh?
Raghava.
He put this question.
Questions we can't see, sir, of him.
So then why he is not joined in the live session when he has a doubt? Okay, you can ask him to kind of contact me also by writing to me. Okay, because since he has taken the course, I don't know, maybe due to some reason he could not able to attend.
Yeah, sure. I'll update in the forum, sir.
Sir, there is a question in the chat section.
I answered, no, Siddharth question or anything else. Siddharth question I answered already. Correct, na Siddharth?
Yes, yes, sir. You have answered. Thank you, sir.
Sir, one more question popped up.
Yeah. Yeah, maybe we are not, so prepared for that. But eventually, because seismology the lab course means, so one can offer the seismic instrumentation recording, H by V ratio measurement and all. So, and then other part of the, like what we have done in engineering seismology, we stopped at hazard analysis. Actually, if we extend a course on seismic site characterization, site response, liquefaction assessment and all, so one can offer a lab course experiments plus the analytical work, which eventually need time to prepare materials and all those things. So right now, there is no plan as such for the current course. Lab course may not be the good idea because our content was not sufficient. Only seismology part we can take like this earthquake recording station and then all those things which can be taken, which is very small component. In case if the course extended for the other application like site characterization, site response studies, liquefaction. So this lab where the theory and lab can be offered. But lab is a video, like I think a video based lab only it is possible. Right now, I think the few video based lab courses are there in the NPTEL, I hope so. This JN Mandal and all people offer in video based one or the in-person lab course?
So it is in person, like the experiment is done and
So
he's
that
shown
means
the
the
readings.
NPTEL person can go there or they will see in the video?
No, no, sir. We can't go there, but we have to see. We can see the video.
That is like recording the video, sir. we had also have the plan, but eventually that requires extensive support from the TA, and then the amount of money paid from the NPTL for preparing the lab course and all very small, because each lab recording will take more than a week, which is not possible to record. Presently, they pay some 3 lakh rupees for the course preparation. So theory course, it's very easy because we can prepare a PPT and then you can run the PPT by sitting in the place. But lab course, whatever, you have to, some of the equipment even you need to procure. So then you have to show the demo. The demo has to come properly. If it is not recorded properly, then we have to redo the experiment. So each experiment recording itself will take a complete week, because there should be a support of animation and proper editing. So to show the results. I'm not seeing how the JC Mandal course from IIT Bombay, but it eventually can be done. I'm also thinking such kind of courses, but since the course material preparation offered from the NPTL is not very attractive, so which eventually kind of end up in doing the poor job, which I was thinking, because the lab course and theory course should not be treated same. Lab course, they have to kind of give the animation team and also the more money for recording the particular experiment, because each experiment, once it's recorded, it can be used throughout his life. But the recording of particular equipment, the quality equipment we need, quality video recording, quality experiment setup, and finally that should be converted as a lecture with all these recordings. Where the regular recording, only 1 hour lecture, if they record it, they can make it as a 2-part, half an hour. So that is the difference between the lab and this. But maybe the NPTL has to maybe come up, because nowadays all the medical things and all, nobody does nowadays all this this one and all. It's everything in the video. People will put here this one and then they can zoom it, and then whatever they can do, they can do. Medical videos are available like that. Similarly, civil also eventually move to that stage soon. Particularly seismology, so earthquake geotechnical engineering also should move on this. Maybe the NPTL team can take note of that and discuss with the NPTL forum, because the lab and theory course right now treated equally. I am correct, no? NPTL office? Karthika? Karthik? Who is from NPTL office on live session? Hello? I think nobody was there.
Yes, sir.
Yeah, so do you listen the answer which is told for the last questions by the participant?
So this is Navin from NPTL.
Navin, did you listening the session also, or only you kept active and moving away?
It's not about moving, sir. Like
Okay, so
last
actually the
question I was-
question was that can the NPTL offer the lab course for the seismology also? Okay, so what I was explained to them, it is possible, but however, there is a kind of huge amount of the workmanship involved in the lab course. So I understand that the lab course and theory course does not have much difference in the NPTL support, correct?
that I'll check and will send it
So
by email.
there is a substantial, because the lab course, each experiment take a 1 week to record and then verify and then bring to the stage of teaching. It takes a more than a week for each experiment. So such cases but even the video will be 1 hour, the background work will be too much for the lab course, because the quality equipment you should have, and then the person to do the experiment should we have apart from the instructor, plus the proper recording and then the animation. So with everything is done, it is possible to offer. But right now, I think I understand that lab course and theory course does not have too much difference in financial support as well as the preparation support. If there is a taken into account, I said I can able to produce that, which you can bring to the NPTL notice. Okay. Yeah.
Excuse me, sir.
Yes.
There is one more session is there.
Okay, we can close. I think we are 59.
Yeah, it shall be close, huh? I
Okay,
think
yeah,
there's no question now so far.
yeah. I can sign
Shall I
out, no?
make end for everyone
Yeah,
meeting? Thank you. Thank you so much.
Thank you, sir.
thank you.